no matter what. Okay, in mechanics we'll call it as a z axis, and that's the first rule. We'll write it down, those rules later. That's the first rule. And if you see there is an axis, this is z, and there is another axis, this will also be z. Okay, so we have two z's here. Now I want to find link length. If I want to know the link length between this joint, so this joint and this joint, what I'll do is I'll draw a two axis, or two axis z axis. And next rule is always the previous joints x axis should be perpendicular to the next one, or next axis z axis, like this. Let me draw it. Which let's go this. Let's say this is my previous joint, and so this is my joint A, joint B. Okay, let's say like that. This is my joint B, and this is my Z here. Okay, and I'll say x-axis should be perpendicular to the current, and it should coincide, or not coincide, should intersect next joints at that axis. That means it should be perpendicular here, and it should intersect the next z axis, like this. So this will be my distance between two joints. This joint will be my two joints. Okay, so that is my a dash I, as is seen here, a dash I. That is my a dash I. And next is link twist, alpha I, angle between two joints. Okay, now we have this joint. So this joint and this joint, they both are not in a like straight in a straight way. They are, let's say, they are 30-40 degrees away, in a different orientation from each other. How will I know that? What will I do is I'll project this, as this is in perpendicular to, right. So I can project this one in the x, and I can find how much angle it is here. See, here I'll just project this one straight here, and I can find the angle, which I'll say alpha I. Okay, any doubt finding these two? Any doubt, guys? Am I mute?
No, sir.
No doubt. Okay, great. So this is, we'll find AI, alpha I. Links are done. Next comes offset and joint angles. Now I need to find link offset and joint angles. What offset is actually, we can say there's a here. If you see this diagram, let me zoom in. Wait, can't move or what? Okay, I can't move it. So this is like a link distance from this to this. There's a link distance A. When I say offset, means it is bit away from the actual joint itself. Okay, link is moving here. This is my link, and I have a parallel, or some kind of weird motion here, and my other joint is here. So there is a distance, right? If I take a distance, that's what distance offset actually means here. So for a distance, it's called di. So how will I find this? Let's say this one for now. Okay, these are two joints here. Another joint. Forget about this one for now. We have two joints here. Let's say this is joint 1, joint 2, and joint 1, joint 2. We have a distance here, right, from here to here. That distance we'll call it JDI. The distance, how far that is. Next is the rotation about joint axis. It's not like they both are in same axis also. They are like in different orientation right now. That orientation, we'll call it as theta. Now you can see not all joints are rotation angles. There are prismatic also. When prismatic comes, theta instead of theta, we will have a deviation in distance because prismatic moves up and down, right? So at that time, these two changes. Like while rotation, we have theta as a variable. It will keep on changing. But in prismatic, we'll have a di as a variable, which keeps on changing. Got it?